Hey everyone! Today we're mixing up an oscillating reaction. I'll talk more about it as it goes, but I want to start mixing. I have 4 solutions here that I need to mix together. The first is a mixture of potassium bromate dissolved in water, and we're going to add that to our beaker. The second is a solution of potassium bromide and some malonic acid. That is also going in. Set that aside. And we're gonna get it stirring because this little magnetic stirring bar is like the greatest thing ever invented. There we go, we'll get that going. Now my third solution here you can see is a bright yellowish orange color. And it's that color because it contains the element cerium. Never heard of cerium? Well, I don't blame you. It's down there near the bottom of the periodic table where nobody ever really looks for things. All the elements at the top of the periodic table, you know, they get all the attention, like hydrogen and carbon, or, you know, big whoop. But cerium, you know, it's down there at the bottom and overlooked oftentimes. But cerium is really cool. And sometimes when I come here and it's quiet, I can hear some of those elements near the bottom of the periodic table just kind of sobbing and crying in the cabinet because nobody ever pays attention to them. Well, now I'm going to give it some love. This tiny beaker here contains a solution called ferroin. And it contains a little bit of iron 2 sulfate, as well as a fun chemical with a fun name called 1,10-phenanthroline. All right, so these two are gonna go in, and let's see what happens. Ooh, wow. That is an ugly green. Yeah. So this is about 20 seconds later. The ugly green is still there. I'm hoping that this reaction will work and then it'll move on into something better. So we'll give it a minute. In the meantime, let's talk about oscillating reactions. Oscillating reactions were discovered back in the 1800s. This is actually one of the classic, I'm gonna say the name wrong, Boleslav-Zhabotinsky. I'm sure I said that wrong. But there are 2 Russian chemists and they discovered that mixtures that contained bromate, bromide, malonic acid, or even any other equivalent carboxylic acid. Ooh, did you see that? That's cool. Now we have a cool, we had like a green color, and now it's shading toward blue. So awesome. There's a lot of things going on in here. You know, that initial green phase was when the ions all got in there, and it's kind of like showing up to a party. You have to kind of look around and introduce yourself and see who's all there, you know, to see what kind of action can happen. Oh, do you see that? Back to sort of a red color. Give it a second. Give it a second. You can, oh, there we go. He didn't let me down. This is an example of a redox reaction or several redox reactions. Redox is short for oxidation and reduction. Oxidation is when something loses electrons. Reduction is when something gains electrons. And a redox reaction just involves the transfer of electrons like currency between molecules. Now I'm going to do something I've never done before. I'm going to run the reaction again, but this time I put a couple of copper wires in my beaker. They're down into the solution, and I've hooked it up to a voltage probe. And you can see already here I've got a small voltage happening between the 2 electrodes. And what I want to do is I want to see what happens to the electric potential as the reaction oscillates back and forth. In we go. Get it spinning. Okay, so what I'm seeing here after a minute or so of running the reaction, that the electric potential inside the solution is actually going up and down periodically. Right now we just turned to a green color, and as the colors change, the electric potential of the solution is actually changing and going up and down with it. There are several redox reactions that are happening in this beaker, and they happen periodically. In a redox reaction, there is a transfer of electrons from one thing that is getting oxidized to another thing that's getting reduced by accepting those electrons. And that is being registered here and detected by fluctuations in the electric potential of the solution. And this is occurring because the cerium ions are fluctuating between cerium 3 and cerium 4. When it goes from cerium 3 to cerium 4, it loses an electron. And also the iron in the ferroin solution I was using is also going from +2 to +3, and they're doing it periodically, and so we see these fluctuations in electric potential.